In most Midwestern states, electricity is sold on the open market like many commodities, with price fluctuations reflecting supply and demand. While commodities like grain are delivered by rail, barge, and truck, electricity is delivered by transmission lines. Regional Transmission Organizations, or RTOs, manage the sale and distribution of bulk electricity to most Midwest consumers. The Midwest Independent Transmission Organization, or Midwest ISO, covers all or part of 11 Midwestern states, with 50,000 miles of transmission lines connecting consumers to 131,000 megawatts of power generation capacity, amounting to $23 billion of electricity sales each year. On hot summer days, the system handles as much as 104,000 megawatts of electricity at a given time. The price of electricity within the Midwest ISO system varies depending on demand and availability. During early morning hours when most people are asleep, demand is low and prices are cheap, perhaps 0 to 3 cents per kilowatt hour. As people wake up and start turning on appliances, lights, and electric heaters, the demand for electricity and the price starts rising. Within the Midwest ISO's footprint, this happens in a wave-like motion from east to west. As people in Michigan and Indiana rise, many in Minnesota, Iowa, and the Dakotas are still sound asleep. The Midwest ISO uses real-time maps with color gradations to show the price of electricity across the Midwest. Cheap electricity is represented by blue, then green. As the price rises, it shifts to yellow, orange, and then red. 24 hours a day, the Midwest ISO operators are in touch with generators and larger electricity users like manufacturers, letting them know what kind of electricity demand is expected at each hour of the day and instructing them on how much electricity to release over the wires and when to reduce their use of electricity. Operators in the Midwest ISO control room are looking at weather conditions and generation data from 250 points across the grid and checking for potential problem areas, examining each data point every 89 seconds. When a problem in electricity flow is detected or predicted, operators are able to quickly calculate a response. The average consumer uses electricity on demand without giving much thought to the time of day or the price of electricity at that moment. For some uses, like lights, coffee makers, or hair dryers, we turn them on when we need them. But other electricity uses, like charging batteries or washing clothes, can easily be shifted from one time of day to another. If people or small businesses knew how much electricity cost at a given moment, and that they could save money or even be paid by foregoing electricity use during expensive peak demand times, many people would change their behaviors. That's part of the idea behind smart grids, to give people real-time information about their electricity use and costs. Such information and planning is central to the Midwest ISO's mission and public outreach. Reducing energy demand during peak times is a win-win situation, since consumers and businesses can save money while reducing congestion on electric lines. Beyond the risk of blackouts or other problems, congestion means that unnecessary price disparities are created because electricity can't easily get to where it is needed most. For example, between 5 a.m. and 6 a.m. in Michigan, electricity might cost 7 cents a kilowatt hour as people wake and begin to use more electricity. But over in the Central Time Zone in Iowa, electricity is virtually free. Meanwhile, as dawn breaks, the wind is starting to pick up in central Indiana, presenting ideal conditions for wind generation. But there is a bottleneck between rural Indiana and developed parts of Michigan, where the power is most needed. So low-cost wind energy, which could be used, is trapped. The way to free that trapped energy is to build new transmission while reducing demand in key areas so that electricity can flow more freely from where it is being produced to where it is needed. Another way to free trapped energy, and hence to sustain and support clean wind power development, is to empower consumers to tailor their energy use habits to the market, freeing up transmission capacity for other uses. We are still very early in the development of customer participation in bulk electricity market design, but the movement is there, pushed by advances in technology and increased customer awareness. The Midwest ISO has focused on goals including building new transmission in the most strategic locations and increasing customers' ability to plan their participation in bulk electricity markets. A major objective is to run the grid as efficiently as possible while maintaining reliability and facilitating clean energy development. This is done in a variety of ways: updating the Midwest ISO software, raising public awareness, giving generators and other players accurate and immediate information upon which to make decisions. It's an evolutionary change with revolutionary implications. When it comes down to it, an efficient grid is a low-cost grid and a reliable grid.